Vanakkam, Namaste, Namaskar. Welcome back to one more session of easy learning and one more concept of chartwork. If you all remember, the last video I had made was for a simple horizontal sextant angle. And let us continue from that. I'll be showing you a new concept today, which is called three-bearing method. This method is used for questions in second mate level also, and as well as mates level. So we'll see a simple way of learning how to go about a three-bearing question. Last session also I was telling that majority of the students find it difficult for finding out which concept is to be used for the particular question. And many questions will be in such a way that you may get confused. Which method should I start off? So I'll give you again clues and concepts. So we'll look at a couple of clues and concepts to start with, and finally I'll give you the conclusion also. So both ways, the first and last slide will guide you how to determine that I should be doing only by three-bearing method. You can see on the topic I've written running fix. So your three-bearing questions are basically related to running fix. So let us see what is a running fix. A simple definition of running fix is that three bearings or position lines, which are also called as line of positions, if they are given at different times, it is called a running fix. And if you remember when we did this, your horizontal sextant angle, we mentioned very similar things. Three bearings or position lines could be given at the same time. So that was more of a simultaneous fix. Now we are going to look at running fix. So three-bearing method particularly talks about running fix. Now, what all type of data can be given? You can see three bearings could be compass bearings given in the question paper, and they could be gyro bearings also. But the simplest one is they could be given as screw bearings also. Particularly for this type of problems, if compass bearing is given, your compass error should be known, which is given to you directly or indirectly. When I say indirectly, it could be using your variation and deviation. Variation might be given in the question or the chart, and you'll be using your deviation card for deviation. Your gyro bearings, if it is given, then gyro error should be given to you in the question paper. So end of the day, for me in three bearing question, I'll be expecting to convert all of them into true so that I can plot it. Now a couple of more situations which can come in the question. These three bearings are normally given from a single lighthouse or a single point. But at the same time, you can get a question where you can get involved with two lighthouses as well. So you should be ready for both the cases. Now, normally whenever running fix is encountered in any question, you will see that you will be forming a chart triangle. And normally chart triangle, I can broadly separate them into two methods called allowing and counteracting. You may not find these words in other books or other videos, but later on I'll make a video which talks about purely allowing and counteracting methods, so you'll understand that also. So right now we are not looking at those two methods. I'll be just using one simple concept and I'll show you how to do it. The meaning of allowing method and counteracting method, as I told you, I'll make a separate video which you can find out very easily. It's a simple concept, how I approach the triangle, how I complete the geometry. So it's nothing very difficult, it's easy. We will talk about that later. Now, one thing you should realize that this method, three-bearing method, which I want to show you, it just gives me only one data called course mate good. Only course mate good, nothing else. So this is something important because otherwise you might do a mistake in the question. A quick question to recap for you. those people who already done chart work, I'm sure you will understand what is a chart triangle. And the chart triangle has got three vectors. So normally, how many data do you need to complete a chart triangle? This is a quick question. The answer also I'll be giving you. The answer is 4. So you need minimum 4 data for you to complete a chart triangle. So in these type of questions where I'm talking about 3-bearing method, you will see 4 data will not be given. And that is the reason I'm going for 3-bearing method. So you will see that in your questions, you might get 2 or 3 data given to you. What are those data? I'll show you in a couple of slides. The upcoming slides will show you those numbers and what are the data. So the moment I don't have enough data to complete the chart work triangle, the first thing I can attempt is to get a CMG, because CMG wouldn't have been given in the question. So this procedure of 3-bearing method gives me only CMG that we have already seen marked with red color. It's very important. That is the reason. There's only CMG, not even your SMG or DMG. There's only CMG. So generally, if 3 data is given to you in the question, then the 4th one is CMG, which I can find by 3-bearing method, and I can complete the question. So let us go to the future slides where it will give you an example, and then we'll look into the conditions also. So different cases can be given. Most of the questions, when you see a concept, you'll have different cases. I've broken them into different cases, but I'll be dealing with only one such case. So this is only a small video talking about the basic concepts. So we'll be dealing with only one such case. So we'll see what is that case. I'm going to give you an example. This is a hypothetical example. Later on, I will try to put this on a soft copy of a chart also, a real chart, obviously. So I'll show you how to do it. It will be somewhat similar to the horizontal sextant angle video where I have used an electronic chart, software chart. Let us take this example. Let us say a vessel was sailing on a course of 065 degrees through with a speed of 12 knots. And while I'm traveling, I observe one light, a single light. And at 8 o'clock, the bearing of that light was 030 true, 8:30 due north, and at 9:15 is 330 degree. And given to me was current setting in a direction of 135 degrees in the area throughout. So what am I supposed to find? The question asks me to find the rate of the current, the CMG, SMG, and as well as all the 3 positions during 8 o'clock, 8:30 and 9:15. One quick important thing for you to realize whenever you are starting a question, we all know bearings are taken from the vessel to the lighthouse or object. So that means that bearing is also your line of position, which means that I'm anywhere on that line. I don't know where. I'm anywhere on that line. But when we talk about plotting the same bearings on the chart, let us take this was the lighthouse. Obviously, we always draw the lines in an opposite direction. Why opposite? Because I'm anywhere on this line, and if I'm on this black color line, always the bearing of that lighthouse at 8 o'clock will be 030. But the way the protocol, what we do on the chart is we draw a small arrow at the end of this line in opposite direction. That is a protocol. So please don't get confused with the direction. And let us say that my vessel's bearing was 000. The vessel's at 8:30 from the vessel. The bearing of the lighthouse was 000. So obviously this is the line. You'll be drawing a line southerly direction and marking this timestamp, which basically means that you are anywhere on the line and always the lighthouse will be bearing 000. Similarly, the last one is your 330. So this is how you will start the question. Since I had given you only one lighthouse as this case, this is one of the cases. So these are the 3 bearings you would have drawn on the chart. I'll show you all these drawings on a chart also later on. Let us first do it on the PPT and then we can understand, then we'll proceed. So let us go for the next stage. Now, the given data for you in the question, please note it down in a sequence to make your life easy. Because if you do it, you can go on a systematic approach, but many people just want to do a just trial and error. It's up to you. But I suggest those people who are in a beginning stage of chart work, I suggest please note down the data in a sequence. And I'm going to give you that sequence. You will see that sequence is quite logical. So let us see what is the sequence. This was the data given to me. Besides this, I was given post-steered, or you can call it post-steer, which is a future. So generically, we can give an abbreviation called CTS. Then engine speed was given to me. And in the question, the set was also given to me. But after that, if you realize rate was being asked, so I don't know. CMG was asked, I don't know. SMG was asked, I don't know. So if you look at these data which I have written on a sequence, it is going to help you to go in a systematic approach. Why? Because these 6 data, if you combine them to each, you can see I have color coded. They represent each as a vector. So number 1 and 2 is a vector, 3 and 4 is a vector, and 5 and 6 is a vector. So the color code tells that they are in a combination. They are always in a combination. I think you should realize CMG, SMG is a combination, second rate is a combination, and course steered engine speed is also a combination. So if you write like this, you realize that I've got only 3 data in this question. He's asking me remaining 3 data. So my first clue and how I use the logic, we'll just see in the next slide. Okay. This is a small word of caution for you. There's nothing wrong, but you'll be wasting time. That is the reason I'm giving you this caution. If already 4 data were given in the same question, please directly proceed by a normal running fix. Do not attempt a 3 bearing method. You will get the answer even with 3 bearing method also, but it is a waste of time. So you need to save time in your exam, because approximately you will see that in any competency exam, second mates or mates, each question you can dedicatedly give it around 20 minutes. You can go 5 minutes extra, but that way you'll be eating off time of a next question. So I would suggest 20 minutes. So you should start timing your question also. So when 20 minutes is there, each minute is critical. So if you try to do with some other method and you don't realize that it's a simple running fix, you're going to waste time. And by the time you realize, you would have lost some good amount of time, which will cost you. Now let us look at the logic. This question, I have broken them into a sequence. Let us look at a logic. Now, if you see at the question, we saw 3 bearings were given at different times. So for me, the first logic was running fix. Then I saw only 3 data were given out of those 6 which I have listed, which means I cannot complete the chart triangle. So hence, I will be trying this 3 bearing method with which I can find the 4th data, which is CMG. So this will be my 4th data. Now let us look at next one. I have this concept, which is, again, it is not a big mystery. If I'm given course to steer and engine speed in any question, I call it as allowing method. Why? Because I'm going to put these two and then let the current or the wind or whatever is given, it can push me wherever it wants me. So that is what is called allowing method. So right now I'm using allowing method. As I told you, allowing method and counteracting method, I will take you in a different video where it will tell you a small change in the sequence of approach in the question. That is the only thing. Otherwise, you can still do it. There's a small change in the sequence. Now, there's a 4th most important criteria for you to approach a 3 bearing method, which means that all the 3 bearings in the question should intersect at one point. And if you see in this particular case, that one point is the lighthouse. So that means I'm satisfying these 4 conditions. So this is what is the logic I have concluded. Now, when I proceed with the three bearing method, I'm going to use a ratio. So that ratio can be based on the distance steamed between the first and second bearing and the second and third bearing. It can be ratio of the time duration between this 1 and 2 and 2 and 3. It could be the ratio of DMG also. So right now in this question, I don't know the DMG. Okay. So that is the reason I can use ratio of distance time or distance steam, or ratio of the times in different periods. So let us quickly have a look. All these questions, if I want to use ratio, sometimes this sentence is used in a question paper, so there's nothing to get confused. Obviously, if the engine speed and current are constant, then only I can use a ratio. So that is the reason this word will be used or a sentence will be used, that the speed and the current are assumed constant throughout the question. So it's very obvious I need this condition to satisfy my solution. Looking at this example, if you realize the time which I have given, I started the question at 8 o'clock and finished the question at 0915. That means I can draw a triangle which is 1 hour 15 minutes, and that is always recommended to avoid confusions and mistakes. So please go it by 1 hour 15 minutes, which is a complete set of the question right from first bearing to last bearing. But there are some people who always ask, can we do a triangle for the first 30 minutes? Why? Because first bearing was 0800, the second bearing was 0830. So I have 30 minutes. I can do a triangle. But I suggest please do not do this, because if you do a mistake in which you have not taken the time equally in all the three vectors of the triangle, you can end up doing a blunder in the question. So it will be a simple mistake, but you will not get the answer. You don't want to do that. So I suggest please go by this last para. Always try to use the duration between the first bearing and the last bearing. So here it is 1 hour 15 minutes. So I am also going to do 1 hour 15 minutes. Let us proceed from here. Now I'm going to show you how to continue from this question step by step. This is the same diagram. I've drawn it bigger so that I can draw the triangle, complete triangle, as well as how to get the fix of all the three bearings and times. Let me start off. The first step, what you need to do is this common point called Romeo, which is the lighthouse. I'm going to draw a line which is perpendicular to the middle bearing. The middle bearing is 830. Even though there is no need for you to do it, you can draw any line, but I suggest please do a perpendicular. It will avoid a lot of confusions, and that is the last thing you want in your exam. You'll be drawing so many lines, you'll be solving 2 or 3 questions where these questions will be overlapping each other also. And that is the time trying to make yourself a little bit easier for you will always help you to avoid confusion. So I suggest please draw a perpendicular line to the middle bearing, which is 830. So it will be like this. This is the perpendicular line. I'm going to use this line as a ratio line. I already mentioned that I'll be using ratios. You can see the ratios from first bearing to second bearing is half an hour. The second and third is 45 minutes, and the total duration is 1 hour 15 minutes. So I'm going to use the ratio. This ratio can be directly taken by the distance, or you can indirectly find out from the engine speed and the time. So whatever it is, you can take a ratio. I can alternately take a ratio of time as well. Let me show you both of them. In this question, my engine speed was 12 knots. Hence, the distance by engine from 8 to 830 obviously is going to be 6 nautical miles. And the next set is going to be 9 nautical miles. If I take the time, we should agree it will be 30 minutes and 45 minutes. If you break down this ratio, you will see both of them are same. All I have to do is divide this time ratio by 5, you will get 6:9. Exactly the same thing. You can go down to a lower ratio also. You will see the same ratio is valid even for 2:3 also. But I suggest try to keep these ratios as big as possible, because your triangles will be big and your errors will be minimal. Remember, in every chart question, you have couple of errors which are not avoidable. Number one, if your chart is a photocopied chart, there are inherent errors. Then obviously, then your instrument errors are there. You can have a plane, your parallel ruler, your divider, whatever it is. And then comes the human error. So if you want to avoid or reduce these things, try to make as big as possible. So I'm going to take 6:9, because if I take 6:9, I feel on my chart I can draw a respectable distance. So let us see that. So with this ratio, what am I going to do? I will start with Romeo as my center. Since I had drawn perpendicular to the middle one, I'm going to take Romeo as a middle part, and then I will use on the left side for 8 o'clock and the right side for 9:15. So you see that I'm going to draw a couple of points using the same ratio, using 6 nautical miles, or I can use 6 centimeters also. 9 nautical miles, I can use 9 centimeters also. I told you I can break down to 2:3, but not preferable. Make it bigger, as big as possible. So please see how I'm drawing the 6 nautical miles or 6 centimeters and 9. I'm going to use from Romeo, I'm going to take 6 centimeters or 6 nautical miles. Similarly, I'm going to go to the other side of my question. Let me just move my. You can see I'm going to use 9 centimeters or 9 nautical miles. I'm going to mark X and I'm going to mark Y. So all I have done is, from the center point, which is Romeo, I have taken the ratio of the second and first and the second and third. This is what I've done. So I hope till now it is clear. Let us proceed further. Now, my next step is from X-ray and from Yankee. I'm going to drop two parallel lines. When I say parallel, parallel to the middle bearing. I'm using always the middle bearing as reference. I use it for perpendicular, and I'm going to use it for parallel. So I'm going to drop two lines like this. This point of intersection with the first bearing is called alpha. And I'm going to draw from the third one, I'm getting Zulu. So I'm going to mark alpha and Zulu. They are two markers. They have a purpose. And please remember, alpha and Zulu are not any positions. So please do not mark them as a fix. No. They are just markers, alpha and Zulu. Please join alpha and Zulu. So when you join alpha and Zulu, what you get is the course made good of your question. So you have achieved the data which you wanted. This is the CMG. And please remember, CMG is one part of the vector which is only direction. Okay, so you have to be careful. And since I said alpha and Zulu are not any positions, so please do not measure this alpha Zulu and try to give that as a DMG, or if it is a 1 hour triangle as SMG. No, this is just a direction. And that is the reason you can see I've extended this green color line beyond Zulu. Otherwise, I could have stopped at Zulu. I've extended beyond Zulu just to emphasize this is only the direction called CMG. There's only one of that particular data which I wrote in sequence, which was unknown to me. That is the only data I have. So let us proceed from here to the next step. I'm going to continue the question from here after finding CMG. Let us see what all data we have and what we can apply. Now, I'm going to use the running fix concept. In running fix, we all know that I can assume my start point alpha at any point on the first PL. And I already have one alpha. So I'm going to start from there. What is known to me? For me, my CTS and engine speed is known. Again, as a recap, alpha and Zulu are not a fix. They are just markers. I'm going to apply my course steered and engine speed for 1 hour 15 minutes so that I can complete a triangle for 1 hour 15 minutes. I told you, preferably, please take the full duration of the question. So I'm going to apply this CTS, whatever it was, and I'm going to measure it for 1 hour 15 minutes with the engine speed. and I get one more marker called Bravo. At this stage, if you look at the question, I had a third data known to me. The third data was your set. Please remember, set is only a direction. So I don't have the rate with me. Set is only direction. I'm going to apply that set exactly in the same direction from Bravo. You will see it will come and intersect the CMG track. It can intersect anywhere on the CMG track depending on the set. Mark that as Charlie. Again, Charlie is a marker. It is not any fix or anything. Now here you have to be careful. Many students in the exam do this small mistake, but it is a very costly mistake. Your whole answers are wrong. What they do is, instead of putting this Bravo and Charlie with the set given to you in the question, they join this Bravo and Zulu, which is wrong. Please don't do it. Many people do this in the exam. So please be careful. Zulu is only a marker, and that gave me only a CMG direction. So I cannot use that. Coincidentally, in some question, it may become a position, but right now it is not. It has nothing to do with the question. So the job of Zulu is over the moment I found out the CMG track. Now I have completed a triangle called Alpha Bravo Charlie. Alpha Bravo Charlie can be called a triangle for 1 hour 15 minutes. Okay. Now what do you normally do on a running fix? The moment I have completed the 1 hour 15 triangle, I will transfer my first PL to Charlie. This is what I do. I transfer my first PL to Charlie. The symbol of transferred PL, please remember, is double arrow on both the sides. These symbols will help you to avoid confusion. Otherwise, there will be so many lines that you will get confused. You don't know which line you are working with. So please mark double arrow on both the sides. This is a transferred PL. Now, wherever this transferred PL intersects the third PL, which is 915 PL, which is the last bearing, is called your last fix. This is already a simple running fix concept. The moment I've got a 915 fix, I know that I would have traveled in a particular direction so that I will have a fix on the previous 8:30 and 8 o'clock also. So this is where we always transfer only the CMG. Please remember, only CMG. Now I'm going to transfer the CMG at 9:15. So now you can get fix at 8:30 also and fix at 8 o'clock also. And you can see I've marked the double arrow again because this is the real scenario. You were exactly at 8 o'clock fix. You were sailing some other course, but the current was pushing you and made you come to 8:30 fix and then 9:15 fix. Okay. Here I can get one data. Obviously, when I measure from fix to fix, I can measure the DMG or SMG. If it is 1 hour, I call it SMG. If it is anything which is not 1 hour, I call it DMG. And do you agree that the distance between 8 o'clock and 9:15 fix is exactly same as Alpha Charlie? So Alpha Charlie is your DMG for 150, 1 hour 15 minutes. So if the question asks you SMG, then you need to convert this for 1 hour. Otherwise, you can write this as an answer. Let me proceed the same question on an electronic chart or a software chart. I'm going to take a chart where I'm showing you bill of Portland. You can see this is a bill of Portland. Let me use this lighthouse at the bill of Portland. Okay. I'm going to use similar data, whatever I gave you in the question. 8 o'clock, I call this Romeo. This is your 8 o'clock bearing. I told you, put an arrow on the bottom of that line which you draw. Put the timestamp. Don't forget the timestamp. So this was 030. Let us say this was 000. And this was your 330 in the question. So I marked all the three bearings. Let me start off proceeding with the steps which I had told you. The same question. I'm going to draw a ratio line which is perpendicular to the middle bearing. I'm going to mark a point called X-ray with a ratio of 6 centimeters or 6 nautical miles. I'm going to draw Yankee, which is 9 nautical miles or 9 centimeter. I'll be dropping two parallel lines to the middle bearing, and this is your alpha and this is your Zulu. Please join them, and this is the CMG of your question. As I repeat again, alpha and Zulu are not fixed, so please do not use it for anything else. Now, alpha I can assume as any point on the first field to start my running fixed question. So I'm going to draw my CTS, let us say 065. I'll put the engine speed for 1 hour 15 minutes. I'm going to mark Bravo. Set was given to me. Please mark the set at whatever direction is given you, 135 in this case. You will get Charlie. Please watch out the symbols for all the vectors also. These are important in your question. So you need on the chart to mark these symbols, single, double and triple arrows representing CTS, CMG as well as your secondary. So I have this Charlie now. Alpha Bravo Charlie is 1 hour 15 minutes triangle for this question. As again I said, please do not do the mistake of joining Bravo and Zulu, it is wrong. Now I have completed the triangle, so I'm going to transfer my first PL to Charlie. So this is my first transferred PL. Wherever the first transferred PL intersects the third PL, why third PL? Because we have drawn a triangle for 1 hour 15 minutes. So I can transfer only to 1 hour 15 minutes. So this is your 915 fix. I'm going to retrace back my CMG, and that is going to give me 8 o'clock fix and 8:30 fix also. And what exactly happened to you in your vessel when you are sailing? You please see my CTS was 065, was this direction. But I was sailing and I was maintaining a CMG of the green color, which is not 065, which is something different. That you can find out when you plot. So this is your actual question of a three bearing method. All we have done is we have realized that we were not given 4 data for my triangle. So the 4th data was CMG. I used ratio method to find the CMG, and then I used the simple running fix method. So let us conclude this one simple case with what we have learned as conditions and clues for your question. You should be careful of one thing. 3 bearings can be given at the same time, but that is simultaneous fix, and that leads to horizontal sextant angle, which we have dealt already with the previous video. You need a caution of this because people get confused regarding this one particular concept, because compass bearings can be given in your HSA method also, and they can be given in this method also. And the biggest difference is this method is going to be different timings, so it is a running fix. That is why it will lead to a 3 bearing method. Now, whenever compass bearings or any other bearings are given, your first job in 3 bearing method is to convert. So please convert that into 2 bearings and plot. We all know that we cannot plot anything else on the chart except 2 bearings. So you cannot plot anything. So please convert that and plot. Now, the condition where I told you earlier also, the 3 bearings should intersect at one point, then only I can use this method. So this is important, mark with red. These bearings could be from a single lighthouse or 2 lighthouses also, but I have taken only one case, which is a single lighthouse. If 3 data are given, the 4th one is a CMG, which is found by this one. Obviously, current was given, it will be given also. Current can be given as only set or only rate, or both of them can be given also. As far as this question gives me only 3 data or lesser, I know the 4th one is your CMG. I'll be choosing between allowing method and counteracting method for running fix. It's a simple concept which I'll take care later. So here this particular question was allowing method. Why? Because CTS and engine speed were given. And this whole method gives me only CMG, nothing else. So this is a condition and the clues which can help you. The first slide and this last slide can help you to figure out how to analyze the concept and conclude, okay, I'm going to do by three bearing method. Gentlemen, that is the end of this short video. We're talking about a three bearing method. I hope it was useful for you. And I'll catch you later once again. And namaste again.